Hello. Welcome to today's POTD video. First, to understand the question that what they are saying us, and then we see the intuition behind it, and then we code up. Okay. So the question name is intersection point in Y shaped linked list. Okay. And they are saying that we have given two linked list, written the point where two linked list intersect, and note if the linked list do not merge at any point, then we have to return -1. Okay, so we have to tell them the intersection point of the linked list. Like in this is one linked list and this is another linked list. Okay, so 4 and 4 are the common part. So the 4 is the intersection point. And in this, as we are seeing that 8 is the common part, 8 is the common value, so we have to return 8. And in this 1, 2, 3, and 5, 6, there is no common part, so we have to return -1. Okay, and the linked list size both of the like a addition in n plus m, let's say their length, then this is 2 into 10 to the power 5. Okay, so let's see the solution that what we are trying to do here. Okay, so what we have to do, that we are given to linked list. Let's say I taken an example that 1, 2, and 3 and 5. Okay, and I have taken another one linked list as let's say here 4, and this is connected to 3. Okay, so as we are seeing that 3 is the common part, and this we have to return. So what we have to do in this, let's say I taken two pointer, because without pointer we can't do anything in this. Okay, let's say I taken one pointer t1 here, and I taken second pointer t2 here. Okay, so what if I make t1 and t2 equal at a point, because at that point only the both linked list are equal, so 4 and 1 are not equal. So I put forward t2 and again put forward the t1, then again put forward t2, then again put forward t1. So what the problem you are seeing here, that t2 and t1 are missing out the common value. So what we have to do, we have to make sure that the starting point of t1 and t2 should be at the equal length from the common point. Okay, so that thing we have to take in mind. After that the problems I think becomes easy if we made this, that what is the common part that we have to take in mind. Okay, so what we do for that common part that we are pointing out, like say, in this t1 at initially not should not point to 1, t1 at initially should point to 2, because in their direction at that point after only if we move forward for t2 by 1, then it come to 3, t1 by 1, then it come to 3, we meet a value that is common, so we return it 3. Okay, so that's the question and that's the thing we have to do. So what we did do first in this, that first we find the common, first we find the length of both the linked list. Okay, so length the both of the linked list, because the common point can only be finding out by the length they're equal, because 4, 3, 5 and 2, 3, 5 have same length of 3, and one is the extra in the another linked list. So first what we did, we find the linked list length. So one is of 4 length, another one is 3 length. So then what we do, the linked list that has the more length. Okay, so like 4 has more length than 3, so how many times it have more length? One time. So one time we have to move the t1 pointer in the second linked list. Okay, so t1 pointer first point here, if we move one time, then it come to the 2. Okay, and then we traverse parallelly both, like while t1 and t2 and t1 not equal to t2. So at the point that t1 t2 equals, we have to return that value. So in this, like if t1 move here and t2 move here, so both become equal, because the same node is present here and both of them have same address. So that's why 3 is our answer. Okay, so let's say I taken another example also, that 5, then 6. Okay, and then 7. Okay, and then 8, and then 9. Okay, and here I taken 1. Okay, so what is the our answer? Our answer is 8 in this case. Okay, so what we have to do first, we find the length of the both linked lists. So one length is 5 and another one is 3. So the linked list that has the more length, we have like how many times or how much number it is more? 5 minus 3. So 5 minus 3 is what? 2. So we have to move the pointer of the linked list that has more length by 2. Okay, so t1 is initially here, then we have to move it by 2. So then one time here and second time here. So now t1 is at 7. Okay, so now t1 is at 7 and t2 is at 1. Okay, so t2 is at 1. Then what we have to do? We have to move parallelly both the pointer, that while both t1 and t2 not equal. So t1 then come to 8 and t2 then come to 8, and we find out the common point that we have to return. So that's our solution. Let's see the code of this. So this is the code that what we are doing here. First, we finding out the length of the both the linked list, that I already said that we have to find both the length. Then what I am doing here, that if count 1 is greater than count 2, so while count 1 not equal to count 2, we have to move the t1 pointer, and same goes to the t2 pointer also, that if t2 length is more than the t1 length. Okay, like a second linked list has more length than first linked list, then we have to move t2 pointer. And in this I am trying to find out the common point. And if t1 exists, like t1 is not null, then we are returning the t1 data, because this loop is only like break when both are equal. So that's I am doing here. And if they are not any equal value, then t1 pointing out to null in final. So at that case I am returning -1. So that's our solution. Let's compile and run this. It's a pretty I think the medium level question, because if we finding out of the fact that we have to take care of the length only, then it become easy. Okay, so it is passing all the test cases. So thank you.